All right, so we are going to move on to chapter 2 here. This is mixed radicals, and we want to simplify them. So, in essence, we want to simplify whenever we've got something like this. So, what is going to be very handy is, first of all, I'm going to try and stop saying so all the time because that frequently happens. And the other thing that's going to be very handy is if you remember your perfect squares. So you should remember all of these. You just take the square of a number, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, so on and so forth, because this is going to be very handy. If you don't know these, it's going to be a little bit trickier. The reason why we want to do this is because using rule number 1 here, just in the reverse, so if I have something with the same root, I can combine them together. I can also do the reverse. So if they're in the same root, I can split it up into its factors. And the reason why I want to do that is I can take a perfect square here, separate them, and then actually take the square root of that perfect square to get a number outside. So I want to be doing these for these examples that we're going to do here. So that's my strategy for what we're doing today. So for example, letter A here is 24. So what I want to do is I want to look at 24 and factor it into two things where one of the numbers is a perfect square. So what I can do, split this up. Yes, I could split it up into 2 times 12. That's not going to help. Okay, 2 times 12 isn't going to give me anything because neither of those are perfect squares. However, I can break it up into 4 times 6. Again, the reason why I want to do that, now I can split this up, the root of 4 times the root of 6, and the square root of 4 is simply 2. And this would give me my final answer. This is simplified into mixed radical. So this is entire radical, this is a mixed radical. The goal of this is to turn it into a mixed radical. Let's try a different one. So here we got root 75. Try and find a perfect square that I can take out of this. So the perfect square is 25. I'm going to show you what you need to do on the test. So either you can show me this step, or you can show me like a step like this. I need at least one in between step to show me your answer. If you skip the middle step, I just give you 0. Just because you need to get into the habit of showing your work. So let's try this one. I could factor out of this a 4. So break this up. Root 4 times, let's see, that's 8. So I'd get 2 root 8. But notice, with the 8, I can actually also take out another 4. So I'd have 2 times root 4 times root 2. So I'd get 2 times, this is 2, so I'd get 4 root 2. Again, square root of 4 is 2, times 2 gives me this 4. So this is your answer here. If you noticed right off the bat that I could split this up into root 16 times root 2, this would save you a whole lot of hassle. But if you don't recognize that right away, it's fine to do this multiple steps. Oops, you can't see that. Here. So it's fine if you do multiple steps instead of just this. That's totally fine. I'm going to leave a few here. You can give those a try with the practice problems. Let's try doing the reverse now. I give you the mixed radical, and you need to turn it into an entire radical. So what I'm going to do with this is I'm going to turn this into a perfect square. So I'm going to, since I want to put it under a square root, I'm going to square this. So 2 is the same as root 4 times root 3, and then combine this under the same root sign. 4 times 3 gives you 12. Do the same here. I want to put it on the square root, so I square it to give me 9 times root 4. This gives me root 36, and so on. So I want this to be under a root, so square it, root 16 times root 5, times those together, you get root 80. So that's the strategy. If you want to go into an entire radical, you just square this term to get it under a square root. That's all you're doing there. All right, let's flip the page. Okay, so why would I want to do that? What's the entire point? Well, the reason why this is important is because if I want to know the ordering of something, so suppose you're given something like this, and you want to know which of these are bigger. Suppose for some reason you lost your calculator, you can't turn it into a decimal, and you need to figure this out. How could you do that? Well, the best way to do it would be to turn these into entire radicals. Put everything inside of a square root, and you'd be able to see which of these is bigger. So let's do this. We're just going to take each of these and put them under an entire square root. I'm going to do this just by saying it. I'm not going to write it out. You will eventually be able to get to this point. So if I want to put this under the same root, I'm going to square this. So 5 squared is 25. Times it by 3 gives you 75. So this is the same as root 75. Again, square the first term, 25, times what's in here. So that would be 5 times 5 is 25, times 2 is 50. So this is root 50. Square this, 4 times 5 gives you 20. So we got root 20. And then 4 times 7, so that would be 28. Now that all of these are under a square root, it's really easy to see the ordering. Root 20 is obviously going to be first, then root 28, then 50, then 75. You wouldn't necessarily have noticed that when you just look at the original question. I need to see the step. Make sure you put that in there. So now I want you to write out the ordering from smallest to biggest, least to greatest. And I want the original question, not the entire radical, I want the mixed one. So the first would be 2 root 5, and then 2 root 7, and then 5 root 2, and 5 root 3. So this is the ordering, and this would be my final answer. So you can do this one by yourself, give that a try, just so you can practice that. But I'm going to move on to example 4. So what I've done before is I did everything in square roots. I dealt with squares. The process is going to be the exact same with cube roots, except I'm looking for perfect cubes, and I'm going to cube numbers here. So instead of doing squares, cubes. That's going to be the only difference. The strategy is the exact same. So we've got here cube root of 16. So conveniently, I've given you a list of the perfect cubes here. So I can factor out an 8. So I'd get cube root of 8 times the cube root of 2. Again, 8 times 2 gives me 16, so that's where the 2 came from. And the cube root of 8 is simply 2. So I've got 2 times the cube root of 2. And we can keep doing this. So I'm going to skip one and do this one. So what can I factor out of 128? Well, using your calculator, getting a little bit of steps, you can figure out I can get out a 27, which is the perfect cube of 3. So take the cube root of that. I got 3 times the cube root of 4. And there's my answer. So that's all you're doing. Find a perfect cube, bring it out front, and then actually doing the solving that one. Let's try the opposite of that. So if I want to put this inside of a cube root, instead of squaring it, because then I would get a square root, I need to cube it. So I'd have to do 3 cubed times what's in here. So 3 cubed is 27 times the cube root of 4. Multiply what's inside, and look at this. We happen to get exactly back to the one that we did up here. So that's your strategy. Again, cube this first term, so 25 cubed is 125. It's a cube root times the cube root of 2. Multiply what's under the cube root, we get 250. And so on and so forth. So that's how you would do the reverse. We can also do the ordering just as before. So we can look at expanding these out. So again, I'm going to do this without showing the work. but I'll talk you through it. So 3 cubed gives you 27, times it by 4, we get the cube root of 108. You might have noticed it's the same as this one. It's the same as the one up here. Nothing surprising. Again, this one, we've already done it. Cube root of 250. Do this one, so 4 cubed, and then times it by 5 will give you 320. So the cube root of 320. And then 5 cubed times 3 will give you 375. Again, I don't necessarily expect with this to do that all in your head without the steps. You can write the steps if you want. But I need to see that you've put them into the entire radical to see the process. And in this one, notice it's actually in order. So this one is in order already. I can just leave it. So that is this section. Again, you can do these extra ones if you want. Make sure that you are writing down the questions that you're having issues with, or if there's something that you're stuck on, you didn't know how I got this number or whatever. As you're writing the notes, put a star beside this, or write the time in the video, and when you come to class, we can go directly to that point and answer the question. Don't just say, I don't understand anything. Explain everything to me. Put at least a little bit of thought into which part doesn't make sense so I can answer that spot specifically.